So in this video, let us derive an expression for lateral displacement. For that, let me consider a rectangular glass slab like this. Let this medium be air. This is glass. This again is air. Now let me draw a normal here at the point A. Normal will always be perpendicular to the surface. Now let us consider an incident ray which hits at the point A. Now it is moving from air to glass. So whenever a ray travels from rarer to denser medium, compared to air, glass is denser. So when light ray travels from rarer to denser medium, it bends towards the normal. So this will be the path of the refracted ray or the ray passing through the glass slab. Its direction will be like this. Now again at the point B, let me draw another normal here. At the point B, it is moving from glass to air, that is from denser to rarer. In that case, the ray will bend away from the normal. Okay, so this will be the path followed by the ray. Okay, this point is actually B. B. Okay. Now actually there is two refraction, one from A to B, and at B the ray came out like this. So this is the emergent ray. This is the incident ray. We know the incident ray and emergent ray are parallel to each other. Actually this is the path of the incident ray. Even which means if there is no rectangular glass prism, the ray will move like this. So this is the path of the incident ray. But when you look at the emergent ray, this emergent ray is parallel to the path of incident ray. So there is a distance, vertical distance or displacement. This is called lateral displacement. So there is a vertical distance between the path of the incident ray and the emergent ray. That is called the lateral displacement. So this is the lateral displacement, or we sometimes call lateral shift. Okay, this angle will be 90. We can call that as x. Okay, now we need to find an expression for x. For that, let me consider this angle as the angle of incidence, the angle between the incident ray and the normal. So this angle, the angle between the refracted ray and the normal, will be angle of refraction. But you know this whole angle I will be equal to this angle because they are vertically opposite angles. So this angle, this whole angle is also I. So this angle will be I minus R. Clear? Because this angle is R. See, this whole angle is I and this angle is R. So this angle will be I minus R. Okay. And let me extend this normal so that it will touch the other side of the glass prism. This angle will be 90 itself. So let me call this point A, B, C, this point D. Okay. Now first consider the triangle ACB. Consider triangle ACB. ACB. When you take the cosine of R, that is cos R is actually adjacent side AC divided by hypotenuse AB. Okay, that will give cos R is equal to, let me take this AC. AC will be the thickness of the glass slab. Let's call that as T, where T is the thickness of glass slab. T divided by AB is the hypotenuse, AB. So that will give, if you take the AB to the left and cos R to the right, it will be AB is equal to T divided by cos R. Okay. So this is the value of AB. Now, let me take this triangle, right triangle ADB. So now consider triangle ADB. Take sine of this angle, sine I minus R. So what is sine I minus R? Sine of this angle. Sine I is equal to opposite side, that is BD, divided by hypotenuse AB. Okay. So BD is actually x, the lateral displacement. X is equal to, if you take this AB to the right, or let me write sine I minus R is equal to x divided by AB. Therefore, x is equal to AB into sine I minus R implies x is equal to AB, we know AB equal to T by cos R. T by cos R sine I minus R. Okay, let me call this as equation number 1. Now, let's expand sine I minus R. Therefore, x is equal to T by cos R times sine A minus B is sine A, which is sine I cos R, sine A cos B minus cos I sine R. Because we know sine A minus B equal to sine A cos B minus cos A sine B. Here A is I and B is R. Now let me take this cos R into the brackets. So T times sine I cos R divided by cos R minus cos I sine R divided by cos R. You can cancel this cos R. So the final expression will be x is equal to T into sine I minus cos I sine R divided by cos R. Call this as equation number 2. Now, let the refractive index of the glass prism be some mu. And we know from Snell's law, sine of angle of incidence to sine of angle of refraction, that is ratio of sine of angle of incidence to sine of angle of refraction, will be the absolute refractive index of the glass slab, mu. Okay, therefore, sine R will be sine I divided by mu. Let's call this as equation number 3. Also, we know cos R will be root of 1 minus sine square R. That is from the identity we know cos square theta, for any angle theta, cos square theta plus sine square theta is always 1. So cos square theta will be 1 minus sin square theta, and cos theta will be 1 minus root of 1 minus sin square theta. Similarly, cos r equal to 1 minus sin square r. Therefore, cos r is equal to root of 1 minus, but we know sin square r is equal to sin I by mu. So, sin I by mu whole square. Okay. So, let me put this, call this as equation number 3. Let me put the equation 3 and equation 4 in equation 2. Therefore, x is equal to t times sin I minus cos I. Instead of sin r, you can write sin I by mu divided by, instead of cos r, you can write this one, root of 1 minus, this is actually sin square I divided by mu square. Clear? Now, if you simplify this, you will get x is equal to t into sin I minus cos I sin I divided by mu whole divided by, you can cross multiply this, so it will be root of mu square minus sin square I divided by mu square. Therefore, see, root of mu square is mu itself. Therefore, x is equal to t times sin I minus cos I sin I divided by mu whole divided by root of mu square minus sin square I divided by root of mu square is mu itself. You can cancel this mu. Therefore, x is equal to, see, this sin I is common, so you can take that out, t sin I times 1 minus cos I divided by mu square minus sin square I. Okay, so this is the expression for lateral displacement. Okay, and one more thing, we know the x becomes maximum, lateral displacement is maximum. This term is, you have to subtract this term from 1. So this whole term must be maximum when this term becomes 0. Okay, that is 1, see, 1 minus a positive term, see, y equal to some 1 minus some positive term. The maximum value of y is always 1. Okay, that happens when this term becomes 0. So this term must be 0 for x to be maximum. Here, if I is equal to 90 degree, then we know cos 90 is 0. So this value becomes maximum when I equal to 90. So you can write t into sin 90 times 1 minus, this will become 0. And again t sin 90 is t itself, sin 90 is 1. So the maximum value of lateral displacement will be the thickness of the glass slab. That is, this lateral shift cannot be greater than the thickness of the glass slab. Clear?